Claim: the mean systolic blood pressure of all healthy adults is less than 121 millimeters of mercury. Sample data: for 287 healthy adults, the mean systolic blood pressure level is 120.83 millimeters of mercury, and the standard deviation is 15.31 millimeters of mercury. The null and the alternative hypothesis are given to be the following. The null is the population mean is equal to 121, and the alternative is the population mean is less than 121, and then find the value of the test statistic. Okay, so we're going to figure out what this test statistic that we need to use. So we're going to first look at the claim here. So the claim is the following. So we know what the claim is, so we can verify what was given. Okay, so here is the claim. Okay, and so normally in part A or 1, we're going to find the claim and then the opposite of the claim. Okay, now we are given the null. So the null is the population mean is equal to 121, and the alternative is the mean is less than 121. So let's verify the claim. Well, the claim says that the mean systolic blood pressure of all healthy adults is less than 121. So the claim would be that the population mean is less than 121, which would mean the opposite would be greater than or equal to 121. So to verify that, this would then apply to the null, because the null always has the equal sign, and the claim goes to the alternative. So we can verify that that is true. Okay, now in step number 3, we need to decide, okay, what formula we're going to use. Well, you can see here that we have 2. Okay, we have the mean, okay, is going to use the t distribution, and that's when the population standard deviation is not known and normally distributed population, or the population standard deviation is not known and the value of n is greater than 30. Well, we would use the normal z distribution if the population standard deviation is known. Now, if you look at this problem here, we have the sample data, okay? And so the sample data is the sample, so that tells us that the sample size is 287, and we have the sample mean to be 120.83, and then we have the sample standard deviation, which is 15.31. Okay, so that tells us the following. That tells us that the population standard deviation is not known, and we can see that the sample size n is greater than 30 because 287 is greater than 30. So that means that we have to use this formula here. Okay, so there is the formula that we're going to use. Okay, so the test statistic is this because of this scenario. Okay, so now in order to find the test statistic, what we need to do is write down the given information. Okay, so the given information is the following. Well, we know from the null hypothesis that the population mean is equal to 121. Okay, and we know that the sample mean is equal to 120.83. So the sample mean is x bar, which is equal to 120.83. Okay, and then we also know that the sample data of the sample standard deviation is 15.31. So the sample standard deviation is 15.31. Okay, and then we also need to know what the sample size is. And the sample size is given to be 287. Okay, So now we have all the given information that we can put into the formula to find the t-test statistic. So let's go ahead and do that. So we have the sample mean, which is 120.83. We're going to subtract the population mean from the null hypothesis, which is 121. And then we're going to divide that by the sample standard deviation, which is 15.31, divided by the square root of the sample size, which is 287. Okay, so let's go ahead and put that in our calculator to determine that test statistic. So in the top, we're going to take 120.83 and then subtract 121. That's in the numerator. Press enter, and there's the value of the numerator. And then divide. Okay, so when we divide, okay, now keep in mind here that we want to contain this in its own parentheses. So that means that we have, okay, parentheses in the numerator 15.31 divided by the square root of 287, and then close the parentheses for that. Press enter, and then we get this result here. So let's go ahead and copy our result. Okay, and now we need to round that to 2 decimal places because it's asking us to round to 2 decimal places. So that means it's going to be negative 0.19 as our test statistic, our t-test statistic. So we're going to get negative 0.19. Press enter, and there is our answer.